we have seen what to do with uniform motion. Now let us look at what is acceleration. The word acceleration means add velocity. Okay, so if I look at this object and let's say this object starts from some velocity and is basically getting faster and faster, we say it is accelerated. So let us take this object and let's say that it was moving initially with 3 meters per second. Now that is the velocity, but that is not the velocity throughout. That is the velocity initially. Now let us say that it has an acceleration of 2 meters per second square. Now what does that mean? This means 2 meters per second every second. 2 meters per second per second. That means 1 second later the velocity will become 3 plus 2. So this is 3. It's going to become 3 plus 2 meters per second. Why plus 2? Because every second you are adding 2 meters per second. Now this is 1 second. What is the meaning of 3 meters per second? You are here, 1 second later you are going to be there. How far away? 3 meters. 1 more second, another 3 meters. 1 more second, another 3 meters. T seconds you would be 3 into t meters. So 3 meters per second means you are traveling 3 meters every second. 2 meters per second square means every second your velocity increases by 2 meters per second. So first second the velocity increased by 2, but originally it was 3, 3 plus 2. 1 more second later, first second, second second. So in 2 seconds its velocity has become 3 plus 2 plus 2. Third second, 3 plus 2 plus 2 plus 2, which I will write it as 2 into 3. Okay, so if I kept going like this, after a long time, let us say 10 seconds, what will the velocity be? 3 plus 2 into 10. Suppose I was traveling for t seconds. What is the velocity there? 3 plus 2 into t meters per second. Now instead of this 3, suppose I had replaced this by 5. What would have happened? 5 plus 2, 5 plus 2 plus 2, 5 plus 2 into t, right? So this would have become 5 plus 2 into t. Suppose I started with a velocity u, this velocity would have become u plus 2 into t. Why 2 into t? Because every second you are increasing by 2. If my acceleration was not 2 but it was a, 1 second later it will become u plus a. 2 seconds u plus a plus a. 3 seconds u plus a plus a plus a, which is a into 3. T seconds it is going to add up as at, and so u plus at. The velocity after t seconds is u plus at. We usually call this velocity v. So you know this formula, v equals u plus at. This is something that Galileo had come up with. We call this Galileo's first equation of motion. But really what is it? It is really the definition of acceleration, right? Acceleration into time changes velocity. We will learn to write this also this way. V minus u is at. Sometimes we learn acceleration is defined as v minus u by t. But basically it is the same thing as saying v minus u is at. All this works when the acceleration is uniform, constant. Okay, it's not uniform velocity, but the acceleration is constant. Okay, so this is 2 meters per second square, 2 meters per second square, 2 meters per second square. So the acceleration remains constant. So here I am saying it's a, but it is the same acceleration throughout. Otherwise, we will have to redefine what we call average acceleration, which is v minus u by t. This is like saying average velocity is displacement by time. Displacement is final position minus initial position by time. So average velocity is change in position by time. Average acceleration is change in velocity by time. We are going to focus on uniform acceleration. So if you take uniform acceleration, then you can write v minus u is equal to a into t. The same statement, you can write it as v equals u plus at. Okay. So now let us do a few questions to just understand this, because this is though it looks simple, there are some small tricky points that we have to think about. Suppose I say I start with 6 meters per second and I'm traveling for 4 seconds, and let us say I have an acceleration of 2 meters per second square. First thing you should do is to calculate AT. What is AT? 8. 8 plus 6 is 14 meters per second. This is how you should calculate the quantity. Now don't remember the formula as v equals u plus at, try to remember it as change in velocity is a into t, because suppose you have a question where instead of u, you are given this velocity. Let us say that my final velocity is 6 meters per second. Acceleration 3 meters per second square for 2 seconds. Quickly calculate this. What is this? AT is 6. So something plus 6 is 16, or 16 minus 6. So what do you think this should be? 10 meters per second. First point. What is this initial? What does it mean initial? Suppose I drop this duster. What is the initial time? Is it the time that I drop the duster? Is it the time that I catch the duster? Initial is whenever you decide to open your eyes. So initial is any time that you choose. Suppose the object was traveling from here, I can say I'm closing my eyes, closing my eyes, closing my eyes. When it reaches here, I'm opening my eyes. So this is initial. And when is it final? Not after the object is stopped or something has happened to the object. Final is whenever you decide to stop thinking, stop looking. Okay, so initial and final is not dependent on the object, it's dependent on us. Okay, the object is moving, we decide whenever it is initial. So please keep in mind, u need not be 0, because for example, if a car was starting from somebody's house, okay, it might have started with 0 velocity, but this is not initial, because I might choose to see the car from here. This velocity is initial. Initial is any velocity you choose, any instant that you choose. This could be initial, this could be initial, that could be initial. So you can say this is initial. If this is initial, you must count the time from here. Final can be that, final can be this, wherever, whenever you feel like. From initial to final, the change in velocity is acceleration into that time interval. So keep this in mind. Second point, usually we will talk about t equals 0 seconds here, but we could say t equals 1 second. This is time instant. This is time interval. Time instant 1 second to time instant 2 seconds has a gap of, time gap of 1 second. So this time is time interval, this is time instant. At this time this happened, at this time that happened. From here to here the time interval was 1 second. This time that we are talking about here is time interval. It is not about the starting time, not about the ending time. It is about the interval between the start and the end. So this is one more point to generally keep in mind. Another important point is about signs. All these values u, v, a, etc. come with signs. So let us look at that. That's very, very important. You can choose any direction you want as a positive direction. That is the important idea in sign convention. So for example, if I choose this to be the positive direction, which is very normal to choose the positive x-axis, positive y-axis is the positive direction. So if I now say that this is 3 meters per second in this direction, it is plus 3. And if my acceleration is also in this direction, 4 meters per second square, it is plus 4. Okay? And let us say that my final velocity is what I want to calculate. And let's say that this was 2 seconds. 4 into 2, 8. So 3 plus 8 is how much? 11. It is 11 meters per second in this direction plus 11 meters per second. But need not be like this, right? For example, it is possible that I started with 20 meters per second and I had an acceleration in this direction. Acceleration comes with direction. Is it that way or this way? If it, let us say, is this way, let us say that this was 3 meters per second square and that is still my positive direction, then let's say that this was basically for 3 seconds. Okay, so is this plus or minus 20? Plus 20, right? Because it's in the positive direction. What about this fellow? It is minus 3. I'm not saying it is minus 3 in this direction. I'm saying it is just minus 3. This is plus 20. Okay, so my final velocity is u is plus 20 plus a into t. So that is minus 9. So you're adding in this direction. You have 20 like this and you're adding 9 like this, and so your answer is 11 in that direction. 20 minus 9 is plus 11 meters per second. So it is in the forward direction. You have to keep this in mind, that everything here comes with a sign. So for example, if there was an object which started out with a velocity like this, it goes like that and it turns and comes back. Let us say that it turns and comes back. Now I know that I cannot have to comes back here, but I'll draw it a little bit below so that it is clear. Okay, so it turns and comes back, and let me say that its speed here was 8 meters per second. Its speed there is 5 meters per second, and it totally took 2 seconds to go from here to there. So this whole thing took 2 seconds. Let us choose this direction as the positive direction. Now tell me, what is the acceleration? Let us calculate the acceleration. Acceleration is final velocity. Why is it final? Because you see, it started like this and it came like that. This is my final velocity. How much is my final velocity? Minus 5. Remember, acceleration is v minus u by t. That is the average acceleration. But if it is uniform, then it is also instantaneous acceleration. So what is my final velocity? Minus 5. What is my initial velocity? 8. So minus 5 minus 8 divided by the total time 2 seconds. Minus 5 minus 8 minus 13 by 2 minus 6.5 meters per second square. Let us think. This means the acceleration is in this direction, 6.5 meters per second square. Is it okay? Yes, because if instead of being this way, if the acceleration was like that, 8 would have become 9, 10, 11, 12. It will never stop. At this point, my velocity has to become 0 meters per second. It will not stop. So it will not stop, turn and come back. So it would have just kept going in the same straight line. So the reason it turns around is because the acceleration points like this. Now sometimes people say that this is deceleration. A very bad term. My suggestion is don't use that. In physics we talk about acceleration. Deceleration also means retardation. These words mean slowing down. It is not the same as negative acceleration. It is not the opposite of acceleration. Right now, is it slowing down? Yes. Is it decelerating? Yes. Is it accelerating? Yes. What is its acceleration? Minus 6.5. What is its deceleration? 6.5. So does it mean whenever it's decelerating, it has negative acceleration? No. For example, this part, from 0, it is now coming towards 5. Is it decelerating? No. It was only decelerating from 8 to 0. It was speeding up from 0 to 5. The opposite of deceleration, the opposite of this is speeding up. Both these, deceleration and speeding up, together is acceleration. Acceleration includes both of these. Okay, so it was accelerating, it is accelerating. Acceleration is minus 6.5, minus 6.5. Deceleration is 6.5. Here it is not decelerating, it is speeding up. Is that clear? The whole motion does not have deceleration. Only part of the motion has deceleration. I hope that is very clear. So we will not use deceleration, we will talk about acceleration. But questions will ask you about deceleration. So whenever you get deceleration, remember the object is slowing down. The acceleration may be positive, may be negative. For example, if I chose this direction as positive direction, okay, and the object was starting off, let us say, with 10 meters per second, and it basically went to 6 meters per second, and let us say in 2 seconds. What is the change? You can start by saying minus 6. What is the acceleration? Final velocity minus 6. Initial velocity minus 10, because this is the plus direction. So this is minus 10. So what is the change in velocity? 10 minus 6, 4. 4 by 2 is 2. Plus 2. Acceleration is plus 2, but plus is in this direction. So acceleration is plus 2 meters per second square. Plus 2. But is it decelerating or is it speeding up? 10, 9, 8, 6. Is it decelerating? Yes, it's slowing down. Is the acceleration negative? No. So acceleration can be positive and the object can be decelerating. Acceleration can be negative, like in this part, acceleration was minus 6.5. This is also minus, this is also minus 6.5. But it is speeding up. There it was slowing down, here it is speeding up. So here it was not decelerating. Here it is decelerating, positive acceleration. Here it is not decelerating, negative acceleration. Here it is decelerating, negative acceleration. So deceleration and negative acceleration are not the same. I know you might have learnt it many times in school and so many books, etc. They are wrong. Okay, deceleration means slowing down. Negative acceleration is the sign of the acceleration. If the acceleration is in this direction, that is plus, this is minus. Here I made this plus, this is in the same direction, so this is plus. So is acceleration plus or minus depends on the sign that you choose for what is the plus direction. Usually we'll choose that as the plus direction. We will not make this the plus direction, but you have the right to choose this or that, whichever you want as the plus direction. Okay, so I hope this is clear. Okay, now let us try to understand how to use this in a couple of questions. So let us look at this question. So in this question we have been told that this is the starting point and that is the ending point. It's given. So this I will call starting and that I will call ending. It's not displacement, just to say S is start. Start and end. Starting, the speed is 6 meters per second. Which direction? Well, if the direction was like this, that means it will have to move this way and then come back. It's not this way because you know the path is this way. It's given that the path is this way. So the velocity must be in this direction. Is it positive or negative? Do that little later. Always draw a diagram in motion. In all physics, in fact, draw a diagram. That's extremely important. Okay, so this is 6 meters per second. And when it is coming that way, did it go, stop and turn? Is the diagram showing you anything like that? No, right? So that means there it's still in that same direction. Now, let us think. This 1.5 meters per second square is the acceleration. Is it in this direction or this direction? Let us see. If it was pointing in that direction, suppose it was like that, then 6 will become 7, 8, 9, 10. When will it become 2? It will never become 2. So clearly this is not possible. So which way should this 1.5 meters per second square be? That way. Is it now positive or negative? We don't know because we have not yet chosen the positive direction. If I choose the positive direction like this is the most common positive direction. We choose it like this. Okay. Then this is plus 6. Notice, even before I chose it, I have the direction. Is it plus or minus? Depends on that fellow. This is plus 6, plus 2, minus 1.5. So what is the time from here to there? Time interval. The big difference between time instant and time interval, I told you earlier, 1 o'clock to 2 o'clock. 1 o'clock is not 1 hour. 1 o'clock, you may have woken up at 6 o'clock. 6 o'clock to 1 o'clock, a lot of time, right? But 1 o'clock is a time instant. From 1 o'clock to 2 o'clock, you have 1 hour time interval. So we are talking about time interval. So what is the time interval? Final velocity minus initial velocity by the acceleration. AT, remember I told you to say AT is V minus U. You should do this mentally many times. V minus U by T is A, V minus U by A is T. So V minus U by A, how much is this? Minus 4 by minus 1.5, and so you get, see this is 3 by 2, so that basically will go up there. It becomes 8 by 3 seconds, 2.66 seconds. Okay, so this gives you the time here. Time has to be a positive quantity because it's time from start to end. Now let us take this fellow, and let us also assume this has positive direction. I don't need it right in the beginning. What direction is the initial velocity? This way. Why? Otherwise it will be moving like that. And then here the velocity must be that way because it did not turn back. It went like that. Now if this is this way, 6 would have become 5, 4, 3, 0. It will never reach 12. So to reach 12 it has to be like this. Positive, positive, positive. Because this is positive. Okay. Now just so that I can confuse you, I am going to choose this as positive. It's my choice. So I am going to choose that as positive. You may want to do the problem with that, but right now what I am going to do is I will choose this as positive. So now what is this? Minus 6. Why is it minus? Not because its direction has changed, but because I chose the positive as being this direction. It's my choice. I can choose what I want as positive. We won't usually do it. Bad idea. We'll always choose that. But you can if you want to. Let us solve the problem by choosing it like this. Now what is the time? Final velocity minus initial velocity by the acceleration. So you'll see that this basically becomes minus 12 plus 6, minus 6. Minus 6 by minus 1.5, minus minus cancel. 6 by 1.5, this is 3 by 2, so the 2 goes up, so that's 12 by 3, 4, so you will get plus 4 seconds. You must be sure that the time is positive. Okay, suppose I did not want to choose this as plus, I chose that side as plus, which is what usually will do. This will be plus, this will be plus, that will be plus. So what is the time calculation? 12 minus 6 by 1.5, again you will see that 6 by 1.5 is 4 seconds. Whether you chose it this way or chose it that way won't matter, you will get the same answer. But the answer for U, V and A will change, answer for time won't change. So I hope that is clear. Now many problems, we drop objects or we will throw objects up. When an object is going vertically under gravity, we say it is free fall motion. Free fall does not mean it has to come down. Free fall can be going up. If the object goes from here to there, that is also free fall. So what is free fall? Throw and leave. Sometimes we learn free fall later when I am throwing it like this. So even this is free fall. But this is not free fall in straight line. This is free fall in a plane. Right now we are talking about free fall in a straight line. So if I drop the object, what is the meaning of drop? Drop basically means you let go. If I let go, what is my velocity of my hand? 0. What is the velocity of the ball when I let go? 0. So I let go, this fellow's velocity is 0. Later on, when for example, if I'm moving in a bus and I drop the ball has the same velocity as the bus. If you're moving in a balloon and you drop, the ball has the same velocity as the balloon. Drop does not always mean 0. It means same velocity as the person who is dropping. Or right now instead of the person, think of my hand is at rest, the ball is at rest when I drop. So drop basically means these two, the person leaving and the object both have the same velocity. So anyway, this is 0. I am telling you that when this thing hits the ground, its velocity is 25 meters per second. Now acceleration due to gravity, you know what acceleration due to gravity is, right? Usually we say it is 9.8 meters per second square in the downward direction. Earth is pulling it. Every object has an acceleration of 9.8 meters per second square. But this is too difficult for calculations. So we will use 10 meters per second square. This is approximate, but for all calculations, if nothing is said, use 10. But if the question says 9.8, please use 9.8. Is that okay? Now let us see. I'm going to use 10. I drop it. So what is this guy's acceleration? 10 meters per second square downwards. G is always a positive number. But is the acceleration plus or minus? Depends on your choice of plus. I'm going to choose down as plus. Why? So this will also be plus. This is of course 0, doesn't matter. This will be plus. How much time does it take? T is final velocity minus initial velocity by acceleration. So the answer is 2.5 seconds. If I had chosen up as positive, this is still 0, this is still 25, this is still 10. Only difference is since up is positive, this will be written as minus 25. This will be written as minus 10. 0 is of course 0. So then what will be the time? Final velocity minus initial velocity divided by the acceleration. Notice minus 25 by minus 10. Of course minus 0 you can ignore. Minus minus becomes plus. So 25 by 10, 2.5 seconds. 2.5 seconds, 2.5 seconds. So I hope this is clear. Now let us do a couple of more questions because then we'll be able to understand this a little better. So let us see that again. Right? I am throwing this ball like that. It goes up and it comes back and I am catching it here. Right? Let us convert this into a question. So I am throwing the ball here. It goes up and then I am catching it somewhere here. Now let me say that when I threw it, initial, its velocity was 15 meters per second, obviously in the upward direction. Why? Because otherwise it will be going downwards if I threw it like this. I can also throw it 15 meters per second this way. That means it will be downwards 15. Remember, initial velocity can be anything, that depends on what you are giving. It doesn't mean just because it is starting, it has to be 0. Starting is not 0. Dropping is 0. I am throwing. If I threw it with 0, it will fall down. It won't go up. So I am giving it a velocity upwards. Imagine that you have a cricket player, right? Suppose the batsman basically gives the bat a nice swing and it hits the ball. Does the ball start off with 0? No, it starts with a very large velocity, right? So starting does not mean 0. Starting can be at any velocity. So this is the start. This is the end. So starts with 15 and I'm now telling you that it totally took 5 seconds to reach here. Similarly, hitting the ground generally does not mean 0 velocity. After it hits, it may stop, which means 0. But when it is hitting or before it is hitting, it comes with a velocity. Suppose this ball falls on my head, it hits me with a velocity, right? It doesn't simply come and stop like that. It comes and hits me with a velocity. This ball hits the ground with a velocity. So what is this velocity? We need to calculate this velocity. Starts with 15, goes down with some v. But I'm telling you it takes 5 seconds. You know that acceleration due to gravity is 10 meters per second square. I can choose any direction I want as plus. What is plus here? I can choose. Sometimes we choose this as plus. Sometimes we choose that as plus. Now let me choose this as plus. What about this fellow? Plus 15 or minus 15? Plus 15. Plus 15. Okay? So I won't write it here. I'll just say it is plus 15. What about this fellow? Plus is that way. This is down. So it is minus 10. This is V. V should be negative. Why? Because that is plus. This is downwards. Let us calculate. V must be U plus A into T. 15 minus 50 minus 35 meters per second. So this speed here is 35 meters per second in the downward direction. Up is positive, so you get minus 35. But this plus minus is what we choose. If I throw the ball, whether I call up plus or down plus, it anyway goes like that. So let us redo this problem by choosing down is positive. Second method. Okay, I am choosing down is positive. That's one method, this is another method. If I chose second method, that is down is positive, what is this velocity? Minus 15, because that was upward plus, this is downward plus, this is minus 15. So V will be minus 15 plus A downward positive, so A is plus 10 into 5. Can you see what is the answer? Minus 15 plus 50. How much is minus 15 plus 50? Plus 35. But what is the meaning of plus 35? Downwards 35. This is still correct. The reality is that it has a speed of 35 meters per second downward. That is going to be correct. Is this plus 35 or minus 35? Are you choosing this as plus? Are you choosing this as plus? If you choose this as plus, that will be plus 35. If you choose that as plus, that will be minus 35. That's your choice. Normally, schools and books and everything else will choose upward as positive and will choose this direction as positive. Normally. Not required. You can choose downward as positive. Except that most people will choose up as positive. I hope that is clear. Right. So you know how to calculate this, right? Now you can do the same kind of problem, but the object may be moving like this. Then remember, this is my initial velocity, this is my final velocity. But if the object started here and went like that, this will be my initial velocity, that will be my final velocity. Okay, I know it's a little confusing, but if you do a few problems, it will start to become very, very clear. So please keep in mind 2-3 different points. U, V, A all have signs. The sign is what you choose as the positive direction plus whatever that thing already has. This A is down. So if this is down and you chose up as positive, this is minus 10. If you chose down as positive, this will become plus 10. But if this becomes plus 10, this will become minus 15. So you will have to basically take that into account. Everything must be chosen in the same direction. 1 plus for the full problem. Don't do things like this, plus plus. I am just showing it to you as a demonstration. You will only take 1 plus. Once you define saying plus direction, fix with it. Don't change it in the middle. So I hope that is clear. Practice a few problems, then this should become easier.